Hey everybody, how's it going today? In an earlier video, I showed you guys how to train a pre-trained YOLO model on a custom dataset. In this video, I plan to show you guys how to use your YOLO model within a mobile environment. More specifically, we're going to be using something called Tensorflow Lite to use our YOLO model on Android. So let's talk about the project that we're going to build. So let's say I give my model an image of coins like I did in my previous video. I want my mobile app to count the coins and give me the denomination. However, the problem is that you can't really run YOLO within React Native or within Kotlin. So for this reason, I'm going to be using a technology called Tensorflow Lite. Now I know that Google a while back changed from Tensorflow Lite to LiteRT, but this is something we're going to handle later on in this video. Furthermore, we're going to be using Expo Native Modules API to perform inference on our Android device. So let's get started. So earlier I showed you guys how to train your model. So this time let's export the model. So when you train your YOLO model, it produces a folder called runs. So this time I have it saved within my PC, runs.zip. So I'll just upload it like so. Okay. First we would have to install our dependencies. So pip install ultralytics. And then I would have to write code to export this model to tflite. So to export my model, first I go from ultralytics, import YOLO, and then my model. So model is YOLO and then the path to my model. So first I would have to unzip this runs folder. So unzip runs.zip. So now it's uncompressed. If I go to runs, detect, train, weights, you see we have our best.pt model. So I just copy the path, copy path, and then I paste it like so. And then to export this model, I go model.export. The first parameter is going to be the format. So as stated before, it's tflite, comma, nms. Let's set it to true. This would make post-processing easier for our results. And then since I don't want int8 quantization, I set int8 as false. So I don't want the installation logs to come up, so I'll do percentage capture, and then I run it, and then I run this as well. And now let's wait. Alright, so a few minutes later, the export process is now complete. Here you can see that we have our tflite files. So let's now test out our models. So I create a new code snippet. First, I would like to copy these tflite models to the root of my project directory. So this time I'll use my best float32 file. So I copy the path, cp, and then my file path, exclamation mark, and at the end, dot slash. So within the same directory, or it's better to just go slash content, slash, and then enter. Okay, so now it ran. And here, as you can see, we have our tflite file. And then to perform inference, I go import. Actually, we don't need import. I just go model equals YOLO and then the path to my model. So this time I'm gonna do the tflite file. And to perform inference, I go model. Here I have to use an image. So let's import an image. I had an image under downloads. Where was it? Archive, images. Let's use this one. ./001.jpg. Results 0.show. Let's see if it works. Nice. As you can see, inference is still working. Let's now use this model within our React Native app. So let's rename it. I call it YOLO.tflite and then enter, and then I will download this. And then let's create a project. Okay, so to build a React Native project, I go npx expo, create-expo-app at latest, and then enter. So here it will ask for the name of our app. So I go YOLO native tutorial, and now we wait. Alright, so now we're done. Let's take this project to VS Code. Okay, so within VS Code, there are a few dependencies that we would need to install. So since we're going to be working with images, I would want to install Expo Image Picker. So I'm going to go npx expo install expo-image-picker and then enter. Okay, so now it's installed. I'll go to app, tabs, and then index. So this is where most of our code will live. So I don't need parallax scroll view. I'll remove this and instead I'll add safe area view to accommodate for my notch on my phone. And I'm going to remove all of this as well. Scroll down, delete, safe area view here, safe area view there. And here, let's try to add a text, hello world. Let's add a style as well. So font size of 18 and color of white. I would like to see how my project is looking. So I would want to run it on my phone. So I go npx expo run Android. And now let's wait for it to build. All right, so now that my code has been built, as you can see, we have our text. So first, let's integrate our image picker. To do so, I'll first create a function. Let me minimize my phone window. I go const pick image, and it should be an async function. So const permission result await image picker. I have to import image picker. So import star as image picker from expo-image-picker dot request media library permissions async. Then we close this panel. If not permission result dot granted. So if the user does not give permissions, I can alert the user. Permission required. And at the end, I just return like so. So return. However, if the user accepts the permission, so I store the image path. So I go let result await image picker dot launch image library, I think, curly brackets, and then my options. For media types, I'll set it to just images, comma, quality, let's set it to 1, and allows editing, let's set it to false. And then if result, so if the result is not cancelled, for now, let's just do a console.log of result.assets. So assets is going to be an array. So I'll get the first one, or in this case, the only element in this array, dot URI. So the path to the image. So let's try to use our function. So I create a button like so. Let's create it here. Button, title, pick an image, on press, pick image, and a self-closing tag. Alright, so let's head back to our phone and let's see if it works. So I do pick image and we now have our image picker. So let's say I click on this photo. So we have a log here. Nice. As you can see, our code works. Let's now move on. We can even display the image like so. So I go image and here I would need the path to my image. So let's create a state variable. So const image, comma set image equals use state. So let's use a generic string or null, and the default value is going to be null. And scrolling down here, let's set it to set image, and here within my image tag, first, as a matter of fact, it's better to check if the image actually exists. So I go image and so if the image exists, I can then render an image source equals and then URI set to my image and then a self-closing tag. So we have an error here. So it's because I forgot to import my image. So within React Native, I go comma image. Nice. So if I pick an image, let's see if it's there. It's not there yet. That's because we don't have a height or a width. So style, 2 curly braces, and here height, let's set it to 100%. So nice. We now have an image showing up. I want to make it a bit smaller. So let's wrap it in a view, and let me put this tag below. Let's set the style. Let's set its height to 65%. Let's now move on to the most important part of our application, which is to integrate Tensorflow Lite. So to integrate Tensorflow Lite, I would need to create a native module. So to create a native module, I go npx create-expo-module, and then the name of my module. So let's call it expo-yolo-module. Or it's better to just call it expo-yolo. Let's keep it nice and short. And then I want it to be local. So --local, enter. So the name of the module, Expo YOLO, it sounds good. Native module name, Expo YOLO, that's great as well. Enter, and now we wait. All right, so now our module has been built. So within modules, we have Expo-YOLO module. Here, I would need to install the Tensorflow Lite package for Kotlin. Since I only have an Android device, I'm only going to show you for this video Android specific instructions. So Android build.radle, and here we can add the dependencies at the end. So it's dependencies, curly braces, and then implementation. So we would need to find the IDs of our dependencies. So let's go back to the browser and let's find Tensorflow Lite, Maven. And yeah, we already have a repository that's being used. Let's use the latest version. Let's copy this one. And I paste it like so. And then we want another dependency for image handling within TensorFlow. So it's called TensorFlow Lite support. Maybe there's a Maven package for that. Yes, there is. Let's find the latest one. I go to Gradle. Let's copy this as well. Go back, paste. And for GPU access, I would need yet another module. So it's TensorFlow Lite GPU and then Maven once again. Nice, we already have a working library. I'll copy this as well. Paste, great. And now we have our dependencies. Just to be safe, what we can do is we can build our module. To do so, within the terminal, I have to close my server. Let's clear it. And then to build the module, I go npx expo run android. All right, so as you can see, we don't have any errors at all. Let's go back to our native module and actually write some code. So within src, within main, within Java, we have these two modules. So only for this video, I'm going to use Expo YOLO module.kt. So within this code base, my first step would be to actually load my model. To do so, I go above this definition function, and we can make a function called private fun. So a function init interpreter. So initialize my model, or in this case, my interpreter. As an argument, it's going to accept the context of this application of type context, and then my curly braces. So I first have to import context. So I go up. Here I can import, let's say import android.content.context, and let's go back down. So let's create a model. So var model buffer equals file util. So import my model from the local files dot load mapped file. The first argument is going to be the context, comma, and then the name of my module. So the first argument is going to be my context, which is coming from the parameter. And my next argument is going to be the name of my model. So we call it YOLO.tflite. And at the end, I can just go interpreter equals interpreter. It's a class model buffer. And this interpreter is going to be a member variable of this class. So let's create it here. Private variable, so var interpreter of type interpreter, question mark, and null. So here I would have to import my interpreter module. So I go up, import org.tensorflow.lite.interpreter. That's it. Let's now create a Kotlin function that we can use within React Native. So within my definition function, here let's create an async function to signify a non-blocking process. Let's call it performInference. And as the name suggests, I want to perform inference on my image. And this function will only accept one parameter, which is the path to my image. So it's URI string and then arrow, like so. For now, let's just do a return at async function. So return for now just the URI. To test it out, we would first need to create a binding. So within my file system, let's go to src expo module, and here we can create our binding. So the name of the function was performInference. PerformInference. It's a function, URI, string, and it returns a promise of type number. That's it. Okay, so now let's use this binding function within React Native. So I scroll up to index.tsx, and I want to run this function every time the value of the image state changes. So I go use effect, curly braces like so, and then square brackets. The dependency array is going to have image, and let's create a small function here. So const perform, actually not perform inference, let's call it do inference. I feel it's better. Equals a sync function, and here let's do const result equals await Expo YOLO. So I forgot to import Expo YOLO. So import star as Expo YOLO from, and then the path to my module at /expo, not expo, modules /expo YOLO. That's it. And then scrolling down, Expo YOLO dot, and then the name of my function. Whoops, I made a mistake here. It's not star, it's just gonna be Expo YOLO. Scrolling down, Expo YOLO dot, and then the name of my function. So perform inference, and here it's gonna accept the path to the string, to the image. So I go image. So we have a type error here. Let's do a check. So if the image exists, then we can perform inference on this. Wrap it in curly braces like so, and then in the end, I can do a console.log of the result. That's it. In the end, let's call this function like so. So I go do inference, and yeah, this seems fine for now. Let me refresh the code. Okay, so then let's test it out. Let me make it bigger, pick image. Let's pick this image again. Okay, so we have an error here. That's because I did not rebuild this project. So I have to close the server. Let's clear it, and then npx expo run android once again. Okay, so we have an error here. Let's see why. Okay, I made some import errors once again. So let's go to the KT file. I forgot to import file util. So I go import org.tensorflow.lite.support.common.file util. Let me clear this, and let's run it again. Alright, so now my project has been built. Pick image, click on this. We have our image, and as you can see, our code works. Okay, so now we've successfully built a native module. Let's go back to our KT file, and here my first step would be to actually load my model. So here first I have to check if my interpreter is still null. If it is null, so interpreter null, then I initialize my interpreter. Here it's going to accept context, and I forgot I have to define the context. So above this definition function, I would have to go private val context new line get equals require not null app context dot react context. Here, as you can see, my app will first import the model. It will import the model from my assets directory. So within Android here, I'll create a new folder, not within Android, within my main folder, assets. Here, let's bring in our model file. So I'll open my files app, downloads, and here is my YOLO.tflite file. That's it. So for now, let's test out if React Native can actually find my tflite file. So I close it again. Let me clear it, and then let's build our project once again. Alright, so now with my project built, let's pick an image. If we have an error, we're gonna see it in the logs. So let me take an image. It came up, and yeah, as you can see, we don't have any errors at all. Okay, to perform inference, it's important to remember that you can't really just insert your image into the model. The model accepts a format called tensors. So we would need to convert this image into a tensor format. So before converting to a tensor, I would first need to convert it into a bitmap. So val bitmap, and then bitmap factory dot decode string. It's not string, it's actually stream, sorry. Context dot content resolver dot open input stream, and then brackets. Here will be the path to my URI. So let's create a variable for this. So val file path equals URI.parse. So parse the URI, and here I can simply just pass in my file path. So now I would also need to fix my imports, just like always. So I go up here at the end, I would need to import the URI module. So import android.net.uri, and then bitmap factory. So import android.graphics.bitmap factory. Great. And then we can check if the bitmap was null. So like if there was a problem in getting the bitmap. So if bitmap was null, we throw an exception, could not decode bitmap. So before continuing with the conversion process, there are a few things I would like to explain you guys. So for example, within netron.app, if we inspect our tflite model, and if I go to images, so here if I zoom in, you can see that my images accept a tensor, just like I told you, of a certain shape, and an output as well, which is a tensor of also a certain shape. I'll now explain you guys what these shapes actually mean. So recall that our input was of this shape. So here my first index, which is 1, is going to be the batch size. So within a batch, we're going to have only one image. The next two numbers are going to be the height and width of the image. So this means that my model wants images of 640 by 640. And my next number is going to be the number of channels. And furthermore, our output tensor was of this shape. So just like before, the first number or the first index is going to be the batch size. The next number is going to be the number of maximum detections per image. And the next parameter or the last parameter is going to be the properties per detection. So in total, so our output array size is going to be of 1800 elements. So this is how the output tensor will look like. These are the first 6 elements of our output array. So the first 4 elements are going to be the coordinates of our detection, and the last two elements are going to be the confidences and the class ID respectively. Alright, so now that we know how our output and inputs will look like, let's now actually move on to the conversion process. So since our images are going to be of any arbitrary size, I would have to create an image processor to process these images. So val image processor equals image processor dot builder new line indentation again dot add, and then we have to resize the image. So resize up. We're going to import these modules later on. Image size, we're going to save this as a variable. I'm going to do that now. So scrolling up, private var image size as 640. This was the image size that the model expects. Anyways, image size, so the height and width, and then the method of resizing. So I'm gonna go resize up dot resize method dot bilinear, all in capitals. Dot add, once again another process within a pipeline. Normalize up, so normalize this image. Norm mean, norm std dev, so the standard deviation. So I scroll up to create variables for these as well. So private val norm mean is going to be 0f, private val norm std dev 255f. You guys don't need to get into the specifics of this. Just remember that it's for normalization. It's only for converting our images to tensors. And then recall that our image should be of type float32 is what the model wants. So I'm going to cast it like so. So cast up data type dot float32. That's it. In the end, we want to build, so build. Let's now import our modules. So I scroll up once again. Import org.tensorflow.lite.support.image.image processor, and then import, actually it's better to copy, paste here dot tensor image, and then import, I'll import till.support, and then paste here dot image dot ops dot resize up. Then I copy this once again, import, paste, and then instead of resize up, we want normalize up, and we're gonna do the same for cast up. Okay, so far so good. Just for sanity, I just want to rebuild my project to see if there are no errors. So close the server, clear once again, and then npx expo run android. Okay, so we have an error. Let's see why. Okay, so we have a few problems. Looks like I made a few import errors. So normalize up, it's not within the support submodule, it's within common submodule, and I remove image here. And the same goes for cast op. So common and remove image here as well. I should have to add support here and support here as well. And yet another import. So import org.tensorflow.lite.datatype. So now let's rebuild the project. Alright, so now our project seems to have built. Let's wait for the app to reopen. Let's pick an image. I just want to check if there are any errors. Okay, so far so good. Let's now move on. So recall that our output tensor was of this shape, where 6 was the amount of properties per detection. So let's create a variable for it. So val props per detection is 6, val num detections. So at maximum there were 300 detections, and let's resize our bitmap image. So val resize bitmap, it's better to call it resized bitmap, bitmap dot create scaled bitmap. The first parameter is going to be the bitmap. The second parameter is going to be the width of our tensor, so it's image size, which is 640, and the height of our image, which is again image size, and the last parameter false. And then let's actually create our tensor. So I go val tensor image is tensor image, and the type is going to be data type dot float 32. And then I want to bring in my bitmap into this tensor. So tensor image dot load resized bitmap, and then val processed image. So the image after processing, image processor dot process tensor image. So process this tensor image and perform these operations. And then we would have to store our image buffer. So val image buffer processed image dot buffer. Then we would also have to store our output buffer. So output tensor buffer dot create fixed size. So we would need to allocate memory for our tensor. So int array of. So the first parameter here is going to be 1, comma, and then the props per detection, comma, and the number of elements. So number of detections. That's it. Then comma, data type. So the type of my tensor, which was float 32. So before moving on, let's now fix our imports. So we have bitmap. So scrolling up here, import android.graphics.bitmap, and then import org.tensorflow.lite.support.image.tensorImage, very long import paths, and then import org.tensorflow.lite.support.tensorbuffer.tensorbuffer. And yeah, so now I think my imports are complete here. Actually, it looks like I made an error. So I imported tensor image twice. Let me remove it. And let's run it again. So npx expo run android. Alright, so now with my project running, let's put an image. And we still have the logs. So it means that our code is still working just fine. Great. Okay, so now we have our input and we allocated memory for our output. Let's now actually perform inference. To do so, I go interpreter to !run and then image buffer, comma, so my input image and where the output should go to. So we've allocated memory, so it should go to output.buffer. That's it. And at the end, I would want to return this output to React Native. So output.float array. Alright, so this means that we're now returning the output tensor to React Native. So before moving on, I will have to fix my types. So I go to Expo YOLO module, and instead of number, it's going to be array of numbers. That's it. Let's now go to index.tsx, and hopefully we should get a valid result. Let me close my server. Let's clear and then run the project once again. So here, once again, pick an image. I pick an image. And as you can see within the logs, we now have a tensor output. This means that our inference was actually successful. So now let's actually look at our tensor output more carefully. So recall earlier, the first 4 parameters are going to be the coordinates, and the 5th parameter is going to be my confidence, and the 6th parameter is going to be my class ID. And the the same pattern can be seen in the next elements as well. So here my next step would be to actually make these results readable to the user. Okay, so I would first need to store my detections within a state variable. So I go const detections, comma, set detections, a use state variable. Let's use generics once again of type array and another generic, curly braces. Let me end it here as well. And so the first field is going to be the class, so the class ID, string, and then a semicolon, and then the confidence number, so the confidence score, semicolon, x1, the coordinates of my box that I want to render over my predictions, y1, once again a number, semicolon, height of type number, and same for my width number. That's it. So let's move on. So I want to perform inference every time my image path changes. So within my use effect, I'm going to create a const detections variable to store local detections. And for now it's an empty array, and then we're going to loop through my tensors or my tensor array. So I'm going to use a for loop for let I equals 0, I less than max detections. This is going to be a variable I plus plus and then curly braces. So let me define max detections. Here let's create a variable, let's call it const max detections is 300. That's coming from the output tensor. And here scrolling down, const offset I multiplied by attributes per box. So I go up once again, const attributes per box is 6. So 6 properties per box. Once again, this is coming from the tensor output. So let's first get the coordinates. So const x1 and my result offset plus 0. So the first element within my array is going to be x1. Same for y1. Let me just copy this. Offset plus 1. Let me copy this once again. So it's going to be x2 offset plus 2. Same for y2. So let me copy this and then 3. Then I would want to get the scores. So const score result offset plus 4. So the fifth element within my array and the class ID. So const class ID result offset plus 5. So the sixth element within my array. Nice. Let's now move on. So here I would want to check if my score is above 0.5. So if my score is above 0.5, I would calculate the height and the width of my box. So y2 minus y1. So the height of my box that I'll render on top of my image. Same for the width, x2 minus x1. And then detections dot push. So an object, so class is going to be a string. So if you guys have not seen my earlier video where I was actually pre-training the model, we had labels. So I'm going to define my labels like so. An array for our labels. So if you guys are not familiar with my earlier video where I was defining a data set, I can show you how the labels look like. So const labels. So a label of 0 was 1 cent. A label of 1 was 2 cent. A label of 2 was 5 cent. And so on and so forth. So 10 cent, 20 cent, 50 cent, then 1 euro, 2 euro. That's it. Okay, so scrolling down, labels, class ID, and then the confidence is going to be the score, comma, my x1 is coming from x1. See, we don't need this. And y1. Oh yeah, I forgot the width and the height. That's it. Now that I've added detections to this array, I would want to update my detections state as well. So right after the for loop, I go set detections and detections. So we have a problem. So instead of class, it's going to be class ID. That's it. So far, so good. And for now, we can also do a console.log of detections. So console.log detections. Let me refresh. And let's test it out. So pick an image of a coin. Nice. As you can see, we actually have our classes and our confidences showing up. So let's actually write our detections or display our detections to the user. So let me just remove this view and then detections.length. So if my detections actually exist. Okay, so there's a TypeScript error. Let's scroll all the way up and add an empty array like so. So hopefully we don't have TypeScript issues once again. Okay, so if we do have detections, so I create a view and here, and a colon text, no detections found. Let me refresh and let's see what comes up. Okay, so far so good. Anyways, if we do have detections, so we loop through those detections. So item, comma, index, arrow function, and then text key. Here I'm gonna put my index as my key, and let's add a style as well. So font size of 18, color of white, just like before. And then here I'm gonna add my item class ID, comma, and let's add the confidences as well. So item dot confidence dot, let's round it to 2 decimal points. Save, and then let's refresh, and hopefully everything works out just fine. So pick image. Nice. As you can see, we have our labels and my confidences. Let's now actually render boxes on my image. So I'm going to introduce a new library, npx expo install react-native-svg. Okay, now it's been added. I will first have to import. So import rect svg from react-native-svg. So scrolling down all the way down. So if an image exists, I want to render my svg box. Let's give it a view and let's end this view like so. We can add a resize mode to preserve the aspect ratio. Let's set it to contain. Okay, so aspect ratio is now preserved, and I want to get the height and the width of the image. So let's create a state for that. So const image layout, comma, set image layout equals use state. Let's set the width 0 and height to be 0. So now scrolling down here, we can go on layout. So when the image comes up on the screen, we have a parameter event curly braces. So set image layout and object width. The width should be event dot native event dot layout dot width, and same for my height. So height is my event dot native event dot layout dot height. Okay, so now we have the height and width. We need this for scaling our boxes to our image. Okay, so another curly braces. I would want to check if my image layout and height exist. Height and image layout dot width, and here we render our svg. Looks like it's not been imported. I'll import it in a bit. Height, and then it's not height, it's image layout dot height. Same for my width, image layout dot width. Okay, so now let's fix our imports. Looks like React removed unused imports from React Native -svg. Okay, so far so good. So now that we have the SVG on the screen, I would want the styles as well. So style position is absolute. The top should be 0, so completely top, and the left should be 0 as well. So completely on the top right. So for every detection, I would want to return a box. So detections.map, item, comma, index, and then arrow, curly braces, return rect from the React Native SVG package, a self-closing tag. And here, my key should be my index once again, and the x coordinates of our image. So x should be item.x1 and then scaled to our image height. Sorry, our image width. So image layout dot width, and y should be, let me just copy this, dot height here and y1 here. Then let's add a stroke of red, and width, let's set the width, item dot width multiplied by the scale, so width. Same for my height, item dot width multiplied by image layout dot height. Sorry, here it's gonna be height as well. Okay, so let's refresh the app. Okay, so here we have errors related to node modules. We have to rebuild our project. So stop the server and then run the server once again. Okay, so now with my project being built, let's pick an image once again. Nice. As you can see, my rectangles are being displayed over my coins. So I want my rectangles to be transparent. So I set the fill to none. Okay, now let's refresh once again. And yeah, so I pick image. Nice. As you can see, my labels are showing up just fine, and my rectangles are also showing up just fine. Pick image once again, and then let's take this image. Okay, so most of these coins are showing up. Let's take another image. Let's take image of this. Great. As you can see, our code works. Okay, so a slight tangent here. RAM nowadays is really expensive, so we would also need to optimize our project. So here, let's now create a function to remove our model from memory. So let's create a function like so. So function close interpreter, and let's set the interpreter to .close. So close the interpreter and free memory from the app. And let's create a binding for this as well. So within my Expo YOLO module.ts file, close, let me just copy this, a function with no parameters, and then it returns a void. And then let's use this function within React Native. So here let's build a use effect function. So as dependencies, no dependencies. And here we would need to do a destructor. So two empty parentheses like so, and expo YOLO.close interpreter. That's it. Let's now refresh our code and we can check if our function works. So let's pick an image. So it's working just fine. Let's make a small change. So for example, let's just do exclamation mark here. And if I refresh the code, my model should close because that destructor will run. Okay, so now that I've saved my project, pick image, take another image. So we should have an error. My close interpreter function is not running because I have to rebuild the project. So stop server, clear, and then run Android once again. Okay, so after refreshing, I made another problem. Here I have to do return, and hopefully this should work just fine. As a matter of fact, let's do a console.log. Resources read. Nice. As you can see, let's refresh the page or the app once again. Okay, so I pick an image. So it's working fine. I pick another image, working fine as well. And here, if I remove my exclamation marks, I should expect my destructor to run. Yeah, as you can see, my destructor ran and my model closed. As a result, I cannot perform inference because my native code is telling me the interpreter has been closed already. This means that my code worked. Alright, let's now try migrating from Tensorflow Lite to LiteRT. This is really simple. It's just a rebrand for now. So first, let's go to build.gradle. We just have to change the package names. So I'm gonna comment this out like so, and then implementation. So we need to find a suitable package. So going to Google here, let's just do Google LiteRT Maven. So we have this link. So we need LiteRT Android API, we need LiteRT GPU, and we would need LiteRT support. So let me just copy this. This is really simple. Let's not use the alpha ones. We're going to use the stable version, which is 1.4.1. So I'll just copy this, go back, paste, and then implementation once again. So for the GPU part, I'll just copy this as well. And then implementation once again, and then TensorFlow Lite support. I copy this once again, and yeah, that's it. That's all we needed for migrating from TensorFlow Lite to LiteRT. After migration, even though all of our imports stayed the same, our app still works just as fine as before. Okay, so a few topics from me. Some of you might be wondering, why build a native module when there's already an existing React Native package? So the problem is that this package has not really been updated as of recently. So while installing these packages, I had dependency issues and it wasn't really working with the newer versions of Expo. And there's another package called React Native Fast tflite, and I had problems using it with my YOLO model. This was confirmed by some of the guys at Reddit, where people complained that YOLO models weren't really working with this package. That's it for today. If you guys have any questions, let me know within the comment section below. I'm also open to suggestions or feedback. In this video, you guys learned how to export a YOLO model to TensorFlow Lite. Furthermore, you guys also learned how to build a native module to use your tflite model, and you guys also learned how to perform inference via this module in React Native. That's it for today. Till then, bye bye.